this is our second example from relationships between lines in space. And they're asking for the shortest distance from a point to a line. And if you remember, the shortest distance is going to be a perpendicular. Yeah, it's going to get there in a perpendicular. The path will be perpendicular to the other path. There we go. Okay, so the first thing I would do is I would take this, which is in Cartesian form, which is kind of annoying, and put it into vector form. So if I forget, sometimes I forget which is the direction vector, which is the position vector. So I might just take, if that's the case, I could just set this equal to lambda or mu or t or s. Let's go with that. So then this becomes x multiplied by 2, that's 2t, but add 1 equals 2t plus 1. And then my y value, that becomes y is equal to 3t minus 4. And, well, we have z minus 3 equals t. So that means z is equal to t plus 3. So if I were to convert this, sorry about this, we'll have to draw that again. X, y, z is equal to something like this, right? So the direction vector are the coefficients there in front of t, and then it's 1, negative 4, positive 3. Okay, so here's the equation of that line. Now I'm going to want to draw that again. So I've got this line, and I've got a point, and I'm trying to figure out what's the distance from the point to the line. So I'm trying to figure out what's the magnitude of this vector that would get me from the point to the line. This is similar to a problem that we did before. This is the coordinate, oh, I just forgot. Point P was negative 1, 2, 3, and this point right here has an x value, well, of 2t plus 1. It has a y value of 3t minus 4, and it has a z value of t plus 3. And so we can find this is P, let's call this Q. We can find the vector PQ by saying Q, the point Q, 2t plus 1, 3t minus 4, t plus 3, minus the p-value. Okay, so minus a negative 1, minus 2, minus 3. And so this cleans up to 2t plus 2, 3t minus 6, and then t. That's nice. Okay, and in order for us to get to this point here, this point Q, then we need to be perpendicular to the direction vector of the line. Well, looking back here, the direction vector is 2, 3, 1. So that's the direction that this line is moving. So I'm going to do the dot product. I want it to be perpendicular, so the dot product needs to equal 0. It needs to equal 0, so we're going to solve for t. So this is 4t plus 4 plus 9t minus 18 plus t. Here's hoping I'm doing my, that's 10t, that's 14t. Oh, I feel like I've seen this problem. We add 14 divided by 14. Okay, so at time t equals 1. So then the question, we want to figure out the question from our page, find the shortest distance. Okay, so this, if we took the shortest distance is going to be the magnitude of this vector PQ when PQ is perpendicular to the direction vector. So I can take this and come and plug it back in right here. That gives me the vector PQ, and then I just need to answer the question. I can find this point, but I don't have to. Hang on. So sorry. I need to know the magnitude of that vector. So let's just come find that vector, plug in 1, and I get 4, I get negative 3, I get 1. And then I just need to know the magnitude of that, the magnitude of PQ, which is equal to 16 plus 9 plus 1. That's 25, 26. And it's equal to root 26. So hopefully that made sense. You want to practice, 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 because it's one thing to understand what I do. It's another thing to do it yourself. So good luck to you.